Hello, this is question 4 from the Cambridge International Exam Series from winter 2019, and it's paper 2-2. You can find a link to an image of this question in the description below. I recommend you try the question first before you're watching my solution. I've wrote out here pretty much all the information they give us. They tell us there's a sequence, and we have x1 equals 1, and then they don't bother telling us x2 or anything like that. They tell us xn plus 1 is equal to xn over natural log of 2 times xn. And they also tell us the sequence converges to a constant, alpha they call it, or a, you might read that as. Now, don't get too afraid by these symbols here, xn and xn plus 1. All that means is the first term, the second term, the third term, depending what number you put in for x. For example, which is what we pretty much have to do now, so let me do it. x1 equals 1, x2, here's my example. N must be 1. If we want to know what x2 is, if I put a 1 here where n is, 1 plus 1 is 2. So we get x2 equals. So that's how this tells us all the symbols. So it tells us that x2 is equal to x1 over natural log of 2 times x1. Or another way to write that is x1 is actually 1 over natural log of 2 times 1, which is equal to, by the magic of editing, it's equal to 1.44270. That's to 6 significant figures. It asks us to write them out. And then x3 is very similar. x3 is just equal to, I'll write this term again, x2 over natural log 2 times x2. Now all you need to do now is really put this all into a calculator. Thankfully your calculator will remember this number. You don't have to type it out each time. In fact, it will remember it to 99 digits. So you can use your calculator. For example, what I would do now is, when I want to get x3, I would put in answer. Answer, on your calculator is a button that says answer. Answer divided by natural log. I'd open a bracket. Your calculator will probably do that automatically. I'd put 2 multiplied by answer. Let me put a little square around that multiply button. Multiplied by answer. Let me put squares around all of these, in fact, because we're putting them into a calculator. And a bracket here. And the calculator will do all this work for you. It will shoot out an answer. That answer will be 1.36147. That's x3. And then you just need to continue to do this. I'll squeeze this all in here. x4 is equal, the same thing, the same similar thing, identical thing to put here. And again, it will shoot out a number for you. In this case, the number will be 1.35914. If we try it again, this is just 6 significant figures. The numbers after this there's more numbers after this. If we do it again, this same set of instructions, we'll do the 5th one, and it will come out as the same answer. In fact, again, these numbers will be different, but that's all they wanted. They wanted to 6 significant figures. Give the result of each iteration to 6 significant figures, and then they just want the answer to 4 significant figures. So I can see that this is we're not going to get any better. If we stay going, we'll just get better in higher orders of significant numbers. Whereas these first 4 significant figures are not going to change. So from this, I can say, let me write it in here, I can say alpha is going to equal 1.359. That's 4 significant figures. And if you stayed going on longer, you could get more and more accurate numbers, but this is fine for what we need. Now, part 2 is a great question. I don't actually need that much room. I could probably fit it up here, but it is a hard question to answer. State an equation satisfied by alpha and hence determine the exact value of alpha. So what on earth are they talking about there? So here's what you need to do. You need to realize that these are thousands of numbers, millions, infinite numbers, all getting closer and closer to the right answer. What we're going to say is right at the end, after infinite number of these iterations, they're going to get closer and closer to being the same as each other. Like 5, the fifth one and the fourth one looks very similar, don't they? They're the same to 6 significant figures. 4 and 3 are close, but not quite. If we go down far enough, if we take a big enough number, like a million, a billion, a trillion, or in maths we say infinite, if we stay going on forever, it's not even a big number, it's bigger than a big number. If we go on forever, there will be 2 numbers beside each other that are the same. So no longer will n plus 1 equal xn, xn plus 1 will equal xn divided by this. We could say these last 2 are the same. So let's change this to just x. Just say x there is equal to the one before it. It's just x, because that's what this says. It's any number is equal to 1 before it divided by the natural log of 2 times the one before it. So these are just all the same, all x now, natural log 2x. That's what they mean by getting an equation. That is an equation that will be satisfied by alpha. Now, how do we solve this? We know alpha is not 0, so we don't need to worry too much about this. So we can divide both sides by x. So the left becomes 1 equals 1, and we still have natural log 2x here. Let's rearrange that. We'll multiply both sides by that. We get natural log 2x is equal to 1. We need to get rid of the natural log. Let's take e of both sides. And the exponential of natural log destroys itself. So we're just left with 2x on the left, and we're left with e to the power of 1, or just e, really. And then solve for x. Divide both sides by 2. X is equal to a half e, or is equal to e over 2. I'd write it that way. And that's it. That's full marks for the second part. That's the equation they were looking for. And that is the exact answer. If you put this in on a calculator, you will get 1.3591409. Actually, 09, I seem to remember, was the number that came up there. So you will get this certainly to 6 significant figures. I think probably to about 7 or 8 significant figures. And this is the exact answer. Now, this one would be miles off. This answer is exact. This is miles off if you go much farther. If you need things to be really, really precise, all these numbers down here are very different than these ones. But still, that's okay. Hopefully that answers that question. Rambling on a bit as usual. If you do have any questions about how I got that, did you get lost anywhere, anything at all, put them in the comments below and I'll do my best to answer. Thanks for watching. Goodbye.